if x equal to u into 1 minus v and y equal to u into v, then so that Jacobian j star that is equal to 1. Jacobian of x y with respect to u v that is equal to partial derivative of x y with respect to u v, and that can be written as the determinant of partial derivative of x with respect to u, partial derivative of x with respect to v, partial derivative of y with respect to u, partial derivative of y with respect to v. If you find out the partial derivative of x with respect to u, then that will be equal to 1 minus v. X is given u into 1 minus v. So if you find out the partial derivative of x with respect to u, then this will be equal to 1 minus v. So partial derivative of x with respect to u is equal to 1 minus v, and partial derivative of x with respect to v, if you find out the partial derivative of x with respect to v, then this will be equal to minus u. So you write partial derivative of x with respect to v is equal to minus u. Then partial derivative of y with respect to u, y equal to u into v. So partial derivative of y with respect to u equal to v. So here partial derivative of y with respect to u is equal to v, and partial derivative of y with respect to v, y is equal to u into v. So partial derivative of y with respect to v is equal to u. So this will be u. So if you find out the determinant, then that will be equal to u into 1 minus v. So u into 1 minus v minus again minus plus, so plus u into v. So that will be equal to u minus uv plus uv. So uv minus uv and plus uv, it will cancel. So that will be equal to u. So the Jacobian of xy with respect to uv is equal to u, and we have to find out Jacobian of Jacobian j with the product Jacobian j star. Now let us find out Jacobian j star. If Jacobian of x y with respect to uv, here we have found out Jacobian of x y with respect to uv, then what will be Jacobian j star? Jacobian j star will be equal to uv with respect to x y. So you will find out now Jacobian of uv with respect to x y, which is equal to partial derivative of uv with respect to x y. And in determinant form, this can be written as determinant of partial derivative of u with respect to x, determinant of partial derivative of u with respect to y, then determinant of partial derivative of v with respect to x, then partial derivative of v with respect to y. And here in this question it is given that x equal to u into 1 minus v, and we have to find out partial derivative of u with respect to x. So x is equal to u into 1 minus v, that is u minus uv, and uv it is given y, so that is equal to u minus y. So what will be u? U will be equal to x plus y. Then if you find out partial derivative of u with respect to x, then that will be equal to 1, and partial derivative of u with respect to y, that will be equal to 1. Now we'll find out partial derivative of v with respect to x. So it is given that in the question that y equal to u into v. So v will be equal to y by u, that will be equal to y divided by u equal to x plus y. So y divided by x plus y. So partial derivative of v with respect to x, if you find out the partial derivative of v with respect to x, then that will be equal to minus y divided by x plus y whole square. Now we'll find out partial derivative of v with respect to y. So partial derivative of v, that is y divided by x plus y with respect to y, applying the product rule. here also we have apply the product rule, and here applying the product rule, that will be equal to x plus y, partial derivative of y with respect to y minus y, partial derivative of x plus y with respect to y divided by x plus y whole square. And if you solve it, this is your x plus y, partial derivative of y with respect to y 1, so x plus y minus y into partial derivative of x plus y with respect to y, that is equal to 1, so x plus y minus y divided by x plus y whole square. So here y cancels, so plus y minus y cancels, so partial derivative of v with respect to y is equal to x divided by x plus y whole square. So we have found out partial derivative of v with respect to x, partial derivative of v with respect to y, and partial derivative of u with respect to x, and partial derivative of u with respect to y. Now substitute the values what we have got in the determinant, that is Jacobian uv with respect to xy, which is partial derivative of u with respect to x, that is equal to 1, partial derivative of u with respect to y, we have found out that is equal to 1, and partial derivative of v with respect to x, we have found out minus y divided by x plus y whole square, and partial derivative of v with respect to y, we have found out x divided by x plus y whole square. So if you find out the determinant, so this will be equal to x into x plus y whole square minus, here also minus, plus, so plus y divided by x plus y whole square. So the LCM is x plus y whole square. In the numerator you have x plus y, so 1 x plus y cancels, so 1 divided by x plus y, and we have found out x plus y equal to 1 by u, and we have found out j equal to u, and j star, that is equal to 1 by u, so j star will be equal to 1. In this way you can prove that Jacobian j with j star, that is equal to 1, given that x equal to u into 1 minus v and y equal to u into v. Thank you.